Alright, today our goal is to teach you how to solve an equation with the variables on both sides of the equal sign, and then we're going to refresh fraction skills and how to deal with fractions inside an equation or when they're set up as a ratio. Right now, you see my little checklist I made. It's kind of to prevent certain situations that kids typically mess up on. So if we stick to this, follow this process, less critical thinking, but cut and dry, do these 4 things, you'll be able to solve them. So first I'm going to do is look at my equation up here. Do I have the distributive property anywhere? Because if things are inside parentheses, we got to remove that parenthesis somehow to get to it. So I don't have distributive property. Check. Do I have any like terms? I forgot to write this on the same side. Ramsey got me. So, as I look on this side of the equal sign, that's what I talk about on the same side. I have a constant and a variable term. Different things. Variable term, constant. Different things. So now I'm good. So, now we got to get the variable on one side. So, here's where typically kids think, oh, what do you do? I do this, I do that. Because there's a million ways you can do this. Different orders. So, I'll discuss a couple. Well, first let's change the people. I have x in 2 spots, here and over here. So I'm going to figure out which one I want to move. If I have 5 over here and I want them to just go away, to be nothing, I will subtract 5 of them. If I have 3 over here, I could subtract 3 of them. I like to keep things positive. Because I don't want to deal with negative numbers. I could lose a sign, very common, because there's so much stuff involved in solving these. So I think about that. I'm going to subtract the 3x. Because what you do on one side, you do on the other. I can't do this because that's not an x, that's a constant. They're not the same thing.
Not like terms.
So we talked about that first. These are. So 5x's can lose 3x's and become 2x. That's 0x, so there's no more of them on this side. Keeping my equal sign since that's positive, and then bring down that. Since this is a positive 2x, I'll put a plus there. So now it's back to what we did the other day. 1 and 2 step equations. So once you've done this checklist, everything turns out to be like this. Done, pretty much. You've mastered the other lesson. So minus your constants here. 2 times something is 34. Then we divide by 2, we get 17. So, here's why I developed the checklist. I'm going to do it a little different this time. Let's say you didn't know this, you didn't do it in this order. Okay. You could come in here and be like, well, I'm going to move this 4 over because it's the first thing I see. Yeah, it makes sense. Okay, so you're left with 5x equals 3x. Whoa, that's a typo, ain't it? See, even I screw up. I understand. I feel your pain. Everybody messes up. Oops, that's actually just a 4. So plus 34. I was getting ahead of myself. So now the variable's in 2 spots. And you tend to get confused here. And what most kids do, just naturally, because a lot of you like to go from left to right, they do this. They go minus 5x, minus 5x. I can do that. Okay. But what you end up doing is getting a negative 2x, and you say it equals 34. That is wrong.
See it all the time.
Yes, very common. But if we move the x's first, there's still something on both sides. It's not always going to work. It's not foolproof. But if you do get in this situation, take the variable that has a constant over there and cancel it out. Move it over. So I'm going to minus the 3x. So 2x equals 34. Same thing we got just a minute ago. So we can divide by 2. Half of that is my age that I act. So that's the Mr. Greg's checklist. Coach Ramsey, anything different you'd like to say?
I think it's a good checklist to follow for sure. It won't get you in too much trouble. Now, obviously, our goal is to get the correct answer. So as long as you're getting the correct answer in whatever way you do it, I'm not going to yell at you. But when you're following a checklist and you kind of get in a routine and doing your problems the same way, you're just going to usually at least have more success. But I definitely like Mr. Greg's checklist. That's a good one to follow.
I'll let Coach Ramsey show you this one.
All right, so looks like we have variables on both sides. Looks like we have a distributive property, right? So going back to Mr. Greg's checklist, the first thing he said was, to look for a distributive property. I think that's a pretty good place to start. So what that means is, in this situation, I'm going to distribute my 2, right? I'm going to distribute the 2 to both of my terms inside that parentheses. Now, this -4, I'm not using that yet, so I'm just going to go ahead and bring it down so that I don't forget. Now I'll distribute my 2. So 2 times a +5 would be a +10, and 2 times a -2x would be -4x, and then that's equal to, nothing's going on over here. I don't have like terms that are on the same side over here on the right, so I'm just going to bring down both of these terms. Right, now let's look and see what we got. Do we have terms that are on the same side of the equal sign that we could combine? Well, we have a -4. We've got a +10. Ding, ding, ding. That's 2 like terms, right? -4 and a +10. And then we have a -4x. We don't have any more x's that are on the left side, so we're not going to mess with that -4x just yet. We're going to combine these 2 terms. So a -4 and a +10, well, that would become a +6, right? I'm going to go ahead and just bring down that -4x, and that's equal to 3x minus 39, right? So now I want to get my variables on the same side. I want to get my variables on the same side. So I got a couple different options. I could add my 4x over here, or I could subtract this 3x to this side. Let's go ahead and just keep our variables, our x's positive, right? Let's keep them positive. So I'm going to add 4x to this side, right? So it goes away here. I'm just left with a 6, and then it's equal to, I've got a 7x now, 3x plus 4x, and then a minus 39. No, it's getting kind of hard to see. Now, we just have a 2-step equation, right? We're right back to what we were doing with our last video. So to solve, to get our x by itself, I'm going to add my 39 over here. Right, so now I've got 45 equals 7x. To get x by itself, I would simply divide. So now I'm going to say 45 divided by 7. Obviously, that gets you a decimal. You're looking at about 6.28. What we got?
Sounds close enough.
We'll call it 6.2.
We're not being precise. We're just going through the process.
Just showing you the process. So now our x is by itself, right? We had x's on 2 different sides of the equal sign. We had a distributive property. So this is, a pretty intense problem. But as long as we follow our checklists, we do the things in the correct order, we can get our variable by itself and find our answer. Right?
Correct. And here we go.
There it is.
So back to the other day, our previous lesson. Copy it down, work it out right now. We're going to go through it. We're just going to solve it, go through it.
Click pause.
Get you a 30-second timeout, fly through it. Okay, I like to draw the line. I don't care if you do. I use this so it makes a straight line. So I'm going to move my no distributive, no like terms. All right, move variable first. Minus 8x. 13x's are here. Bring down the minus 9. Negative 35. There's my variable. And this is another thing, remember, there's your variable. Get rid of what's with it. So on that same side. Add 9, negative 26.
wait, Mr. Greg, your X is on the right side. Is that still right?
You said right twice, so I guess it is. I don't know. Well, we can fix that. There's a thing we can do. We can switch it. Well, that ain't going to work. I can't use that tool. Is that better? I got X equals -2. So, I get what you're saying. Remember, you can always flip them around. Alright. Here's our second example again. Call timeout. Do your thing. Then we'll give you the answer.
Click pause. You give it a try. All right. Hopefully you guys are working these out. Right, not just waiting on us. But real quick, kind of similar to our last problem, there's nothing to distribute. There's no parentheses. We do have variables that are on opposite sides. We know we're going to have to get them on the same side, but at least at some point. Do we have any like terms that are on the same side? No. No like terms, right? So let's go ahead and just try to move our variable to the same side. So we could either subtract 48r, or we could subtract 7r to this side. I'm going to subtract the 7. Again, I like to keep my variables, I like to stay positive, right? I like to stay positive. So 48 minus 7 is 41r minus the 56 equals 26. So now pretty quickly we got a two-step equation. You guys should be getting pretty good at these, right? So we're going to try to get this r by itself. So that looks like I'm going to have to add. I'm going to do the opposite of what's going on over here. So I'm going to add 56. I'm going to add 56. Right? We can make our line. So 26 plus 56. Well, if you want to do it the old-fashioned way, 56 plus 26 is 82. So we got 41r, and that's equal to 82. So real quickly, we just do a quick division. 82 divided by 41. I think you guys can handle that one in your head. So we've got r equals 2. You can always take this 2 if you're a little unsure. Plug that 2 in for both variables. Plug it in for both r's. See if it equals out. It will. R equals 2.
Here's another example. A little different.
Ooh.
Trying to make them a little more very bigger for you.
Remember your checklist.
The first thing is distributive property. Alright, put it down. -3 times each. Oh, remember, pause it. Go ahead and work it out. -3n. 16 minus 5. 7 plus 5n. I'm sad. I'll go blue. Alright, so I'll look at this. There's some like terms. Yeah.
Ooh, yeah.
I ain't going to say I got $18 minus 5. I got 13. Let's just save time. Let's just call it what it is. That's 13. Not 18 minus 5. Then the next thing I'm going to do is move variable one side to the other. Doesn't matter which one. I don't like negative things, so I'm going to add 3. Clean this problem up, as you can tell. 13 is equal to 37 plus 8 n's. And again, that's 2 steps. Subtract and divide. Subtract 37, -24, with 8n, divide by 8, and n, okay, I want orange. N is a UT color. I'm more of an LSU fan though. N equals -3.
Can't forget that negative sign. If you do all this correct and get the wrong sign, it's going to be all wrong. So make sure you're watching for your signs.
Another example that we're going to do.
Ooh. Real quick, click pause. You work it out on your own. I'll give you a hint. Start with your distributive property, right? Click pause, give it a try. All right, hopefully you got to an answer. You may have already checked yourself and you know you're right. Let's work through it together and just simply see if we're all correct. So again, like I said, we'll distribute. Going to distribute first. We didn't have anything over here we could combine. There's nothing over here quite yet we can combine. So we're going to distribute first. So a -2 times a +5 would give me a -10. -2 times a -3b. I see a lot of times kids will forget this sign here. We're not multiplying it just by a 3b. It's a -3b. So negative times a negative becomes a +6. They're going to look kind of, I'm going to write a little capital B here. 6b. Don't forget about our other term over here. We're simply going to bring it down, so it's a +3. I'm going to bring down my -12 and my 7b. We didn't do anything over here. So now, let's see. Do we have any like terms on the same side that we can combine? Over here, no, they're different. On the right side, we got a -10, a +6b, and a +3. That's like terms. Well, let's go ahead and just simply combine my -10 and my +3. Right? A -10 and a +3 would combine to a -7. Oh, got an interruption.
Good morning to everyone. Just want to take a moment to say it was good to see everybody that's here this morning. This announcement is directed towards those who are new teachers or just new to our campus.
We're not new.
If you haven't had the
We're not
opportunity to check your email.
But again,
I sent
we've
one
got
out on this purchase.
no like terms on the left side,
I sent one out last
no
night.
like terms on the right side. So we have got to get our variables, the b, I know it's kind of hard to see that that's a variable, the variables on the same side.
We're going to meet in the auditorium.
I'm going to subtract my
It
6b,
shouldn't be too terribly long, maybe 30 minutes at that.
subtracting my
And I'll
6b.
take any questions if it needs
So now I've got -12,
But again, check your
then
email.
7 minus 6b.
Teachers or new to the building or
That gives us a +1b.
Thank you, and everybody have a great day.
You don't have to write the 1. I'll go ahead and write it just so we can see it. And we're left with a -7. Now, all we got to do now, we got a two-step equation. In this case, it's really just a one-step equation. I'm going to add my 12 over. Add my 12 over. So now, 1b, so my b's already by itself. B equals 12 minus 7. What's 12 minus 7? B equals 5. Right? Hopefully this is what you got. Maybe you guys are getting the hang of it.
Awesome. And we got one more example for you here. I'm going to show you some other things. Bam, up, close sideways. Yeah, we go. So,
Quick pause. Give it a try.
this one's a dirty one, so I'm going to clean it up. My pen in hand. Alright, checklist, distributed property first. Bam. Remember your checklist, you probably wrote it somewhere. Look, the pen's getting weird. Gotta smack it sometimes, shake it up. Alright. Variables both sides, there's no like terms. Oh, this is going to be an easier one. I can minus that or minus that. Yeah, I'm going to subtract the 8x's so everything stays positive. Positive. Minus 8x. Minus 8x. 56x plus 2 is equal to a negative 32. Alright. Again, math's two-step equation minus this constant. The variables over here dictates our thinking, so get rid of that. So negative 56 is equal to 56 times something. This pen's really bad. I got. Alright, divided by 56. X is, you got it, -1.
-1. -1.
Next slide here, we have a big one. We're not going to say a word, we're just going to fly through, work it out really quick, and then let you check your work, see if you've mastered this. Then we'll go over some special cases in the next one, like your infinite solutions or all real number solutions, and then the situation that arises where there's no answer because it doesn't work. Kind of like 2 equals 6. It's kind of weird because it's not true. Again, if you don't have your checklist and it's working for you, awesome. If not, I don't care. As long as you get the correct answer, we do not care. For the ACT, you want to go as fast as you can with these. So you don't have to write everything down, but for our classes, I want to see what you're thinking. So show some work so I can kind of see what you do. And when you get the problems, it might have like decimals, tons, nothing but decimals, which I will give you an assignment. You'll have to write it down because you can't keep up with 4 decimal places with every number. So, and it's not for punishment. It's just to see if you can keep up with things. Practice taking your time, working through the tedious ones. The other half of our lesson will be dealing with fractions, so we'll give a quick overview of all fraction skills here in a minute, going from adding, subtracting, to multiplying, dividing. Give you some tricks if you're not the best with multiplying and you don't know your numbers that well. Give you a few strategies to use. And again, when we get to that section, if you like changing fractions to decimals, we don't care. However you can do it, the quickest way, because for the ACT, speed matters. 60 questions. That's a lot to do in 60 minutes.
X equals 3. Hopefully you guys took the time to work this one out.
All right, Ramsey will show us the next slide, which will have the special cases. So sometimes you'll get negative some number plus that same number should equal 0. Well, if I combine those like terms, the variable goes away. We get 0 equals 0. Hey, that's a true story, right? True.
That's
0
correct.
equals 0. If this is how your problem ends, that's going to be an all real or infinite solutions. Because if I plug in a number, let's say n is 2, does negative 2 plus 2 equal 0? Touchdown. Alright, if I plug in 5, negative 5 plus 5, does that also equal 0? 3-pointer, yeah, all day. Oh, sorry, that was a field goal. Let me give you a 3-pointer this time. Wait, that's touchdown. I'll eventually get it right. One of those is going to be correct. Alright, so that's your all real situation. And if you work it out, you somehow get 2 equals 2. Same thing. Same thing. It doesn't always have to be 0 equals 0.
If it's true, then all real numbers.
Alright.
Over here, negative 3x plus 3x equals negative 2. So if I've got negative 3x, and then I add 3x, well, that's going to cancel, right? 0. And then over here, all I have is a negative 2. Does 0 equal negative 2? Is that true? No. So if you're left with a 0 equals 2 or a 0 equals 7, well, that's no solution. No solution. You might see something like this, or you might just see a no saw. Just know that if your final answer, you're left with something that's not true, it's no solution. Now, don't get me wrong. Sometimes we might make mistakes and we accidentally get this. But, if you're left with a 0 equals negative 2, 0 equals 5, 0 equals 10, it's not true, no solution.
We'll clear this and get us some more space so you can see these last examples. So, here I've got distributed property. So, what's that? Distribute times 2. We're going to get 2x plus 6 equals 6 plus 2x. Well, my pen just broke. See, it's flimsy. It's bends. That should be a 2x. I'm having bad luck with these pens. Alright. So, if you look at it closely, they're actually the same thing. You got 2x and 2x, 6 and 6. So if they're the exact same, it's going to be all real, just like the one I did before. Infinite many solutions. But let's say you didn't recognize that. You're using my checklist. Let's just go through it. Minus 2x. Minus 2x. Gone, gone. So we're left with 6 equals 6. Just like before. Is that true? Yes, so any number is going to work. No matter what we plug in here, it's going to be the same answer. Because if you double a number and add 6, you double that same number and add 6, you're always going to get the same answer.
So real quickly over here, remember the checklist, there's nothing to distribute. We don't have like terms on the same side. So we're going to get our variable on the same side. You might have already kind of picked up on what's going to happen. If I subtract 5x over here, so it goes away here, well, it goes away here, and then I subtract my 10, well, I'm left with a negative 16 equals, 0, because there's nothing left over here. That's not true. 0 does not equal negative 16. So again, this would be a no solution. And you will see these. There will be some of these possibly on the ACT, on the EOC. They're going to be throwing you some curveballs, try to make you get confused, whatever. Remember, if it's, 6 equals 6, 5 equals 5, that's true. There is all real numbers, right? Infinite solution. If it's 0 equals 5, 0 equals 2, 0 equals negative 16, not true, no solution, right?
All right, that's the first half of the lesson. Now we're going to jump to the fractions part. Be pretty quick. So here's your nice screen to look at. Add, subtracting fractions. You just got to make sure the denominator is the same. If it is, then you're just going to add, subtract the numerators. But that's a big word I never understood. Here's your cliff note.
Numerator, denominator.
Top's numerator, bottom's denominator. There we go. So we'll do a few here. Denominator's same, so just add the top. So that's going to equal 3/4. Denominator same, add the tops, because that's what it's saying to do. 5/8. 47s are the same, so 11 minus 3, 8, 47.
I bet y'all like this stuff.
Different color, black, there you go.
Okay, over here, so we got the same denominators. Now we are subtracting this time again, so maybe a little confusing, but don't let it confuse you. Denominators are the same. 14 minus 27, right? So it is a negative 13 over 15. Negative 13 15ths, right? Over here, denominators are the same. Lucky number 13. We're going to add the fractions. So we're saying 12 plus a negative 3. Don't let that confuse you. 12 plus negative 3 is the same thing as just saying 12 minus 3. 12 minus 3 equals 9 over 13. Right? Next slide.
All right, so what happens if they're not the same?
Ooh.
I'm going to level with you. This is the hardest part for some kids. I get it. Because you might not know your multiplication table. So what I'm going to do is show you a little trick if you don't know that the common denominator here is 6. So we'll pretend you don't know it. 1/6, 1/3. Well, I can double this fraction, and it's still the same ratio, timesing it by 2, the top and bottom, and it's 2/6. So now the denominator is the same, and the answer is going to be 3/6. Well, you don't know your multiplication, so what I do is I take the denominator of this one and multiply that whole fraction by it. So I'm going to go times 6, times 6. I'm going to do the same thing. I'm going to take this denominator and multiply this whole fraction by it. Times 3, times 3. And then we will get new numbers. So we'll have 3/18 plus 6/18.
Hey, now they're the same.
So the answer to this is 9/18. But that's not simplified.
What should we do?
Well, if you got a calculator, some of those will reduce it. So I can teach you that in a different lesson if you don't know it. What number divides into 9 and 18? That'd be 9. So divide the top by 9, you get 1. This by 9, you get 2. 1/2. So 1/2 is actually the answer. And there we go. Same thing here, we can multiply. So what we want you to do now is pause it, try these. These will be the difficult ones. So you got your time out.
Click pause, and now we're ready to go.
And Ramsey will do those two for you.
Okay, we'll start up here at the top. So we got 4/7 minus 1/6, right? Denominators are not the same. You got a couple of different options. You could try to find your least common denominator. You could. Maybe we don't know our multiplication tables, whatever. Let's just go ahead and just multiply our two denominators together. Like Mr. Gregg said, we'll take the 6, multiply both of these terms, the numerator and the denominator, both the numbers. Take the 7 over here, multiply it by both numbers. Right, so we'll do that. We'll multiply both the 4 and the 7, the numerator and the denominator, by 6. Right? So now I've got 24 as my numerator over 42. And I'm subtracting, oops, where's my little, multiplying by 7, by my numerator and denominator on this side. 7 times 1 is 7. 7 times 6 is 42. Now my denominators are the same, so I'm just going to subtract my numerators. 24 minus 7, well, that's equal to 17 over 42. Right? Okay, down here on the bottom, 3/8 minus 2/11. Well, we're going to use the same process here. We'll multiply our denominators together, or multiply the 11 over here, the 8 over here. Right?
Oh, you need some space there.
There we go. So times by 11. Right? So 11 times 3 would simply be 33. 11 times 8 would be 88. Now I'm going to multiply by 8 on this side. 2 times 8 would be 16. 11 times 8 would be 88. So 33 minus 16. 33 minus 16 would be 17 over 88. Now, could we reduce 17 over 88? Maybe you're not quite sure. I'll go ahead and tell you you could.
17 is a prime number.
17 is a prime number. Can we reduce up here 17 and 42? Could not. Right?
Next skill is by far my favorite. Multiplying fractions. You just straight up tops times tops, bottoms times bottoms. So 2 times 4 is 8. And then 5 times 8 is 40. Same thing with this one. I just wrote it 2 different ways. This is probably the more common way because we're dealing with equations. They're going to use parentheses. 1 times 8 is 8. 7 times 9, 63. And we're done, except up here we didn't simplify it. We divided by 4 or 8. Let's say you divide it by 4. And you got 2/10. Come on now, Pen. Again, this one broke too. Oh,
Breaking the board.
yes. I think it just don't like me. This pen's broke, so let's get a different. Alright, 2/10. There we go. Well, that can be divided by 2 again, so we're going to have to divide it again to get 1/5. And my brain's backwards. Very common. Everybody does it. So 1/5. That's multiplying fractions. Straightforward. Dividing fractions.
Ooh. Dividing fractions. Hopefully this is something you have seen before. What's that trick you got to do before you can divide by a fraction? Remember, it's very similar to multiplying by fractions, but first, all we have to do is flip-flop.
Flip thing, same, something like that they say.
So we're going to make the 9 become the numerator, and the 4 is our new denominator. Now we're simply just going to multiply straight across. So all I did was flip one of my numbers here. I flipped it. Now I'm going to multiply straight across. 2 times 9 is 18. And 7 times 4 is 28. Reciprocal. Now, we can reduce this, right? We can reduce it. Let's just go ahead and just divide both the numbers by 2. See what happens. 18 divided by 2 is 9. 28 divided by 2 is 14. Will that reduce any further? It will not. 9/14. So 2/7 divided by 4/9 is 9/14.
Right. Now we're going to take these fractions and just shove them right into equations. This is the fun part. Yay! So here we'll discuss ACT for a minute. When I look at this, I can handle a 1/3 x. I know I can subtract this constant then pretty much times 3, because that's a reciprocal. Flip it, work it out real quick. If not, and you're horrible at fractions, you absolutely stink at it, there's a trick we can do to cancel out the fractions. Just like down here, I wouldn't suggest it here, but if you need to do it, go ahead. Find the common denominator with all your terms. Well, here it's 1/3, so it's 3. So we're going to take distributive property and times every single thing by 3. And that's going to get rid of all the fractions. So why can I do that? Well, we're saying this is equal to that. It's kind of like if I go buy 5 shirts for $10, right? That's a true statement. It's equal. If I triple what I buy, so 15 shirts, shouldn't that triple my total? Yeah, it makes sense. So that's why we can do this little trick and get rid of those fractions. Now that one just looks noisy. Alright, so we just times everything. So 3 times 1/3 is 1x. 3 times 12 is 36. 3 times -4, -12. And now you know what to do, minus that, so the answer is -48. So that's one way we can do it. I could minus 12. This is what I would do. Minus 12. So 1/3 x in my head is equal to -16 times 3. Cancels that out. Becomes 1x times 3, -48. Same answer. Didn't I get -48?
I think so.
Yeah. So -48. So there is one way to do it. So here, let Ramsey discuss this one. We got 3 different fractions.
3 different fractions. So this one, when you first look at it, you might get kind of confused. Maybe you're a little nervous about it. I understand, but we can't let fractions get us down. We can't be scared. So we're going to kind of do something really similar to what Mr. Greg just did. We're going to multiply by 20. Everything's going to be multiplied by 20. Each term, right? Multiplying each of these terms by 20. So 20 times 1/4. 20 times 1/4. You could use a calculator if you wanted, or you could say 20 times 120 divided by 4 is 5. So now we got a whole number, 5. And then 20 times my 3/10 x. Well, 20 times 3 is 60. 60 divided by 10 is 6. So I'm left with my 6x, right? Yep, and then 20 divided by my x over 20. Well, that just gives me my 1x. Right? So now it looks a little wonky. What do we got to do? What has to be on the same side? Hopefully you're already kind of working ahead. Let's get our x's on the same side. So I'm going to subtract my 6x. Right? That goes away. So now I'm left with 5 equals 1 minus 6, or 1x minus 6x is a negative 5x. Right? Still not done yet. Our goal is to get our variable by itself. So to do that, I'll divide by -5. 5 divided by -5. -1. Again, make sure we're getting our correct signs. Can't forget that negative. X equals a -1. Right?
Something I see my students complain about or be confused is this part right here. That's x divided by 20. Well, we can rewrite that since that's a 1 there as 1/20 x. So if you need to rewrite it that way to help you see it better, you can. All right, let's move on. We've done bored you enough. We got like 3 slides left. So again, try this. Do your best on it.
Pause.
Oh boy, yeah. This one we got some strategies. So these 2 fractions can actually become decimals. Hey, some people like decimals. They're not repeating. So you can right off the bat call that 0.5 or 5/10 y minus 3 equals 0.75y minus 21. If you like it that way, work it out. If you don't like decimals, where you lose it, you don't like fractions, well, multiply like the common denominator. Everything is times by 4, and everything will then become a whole number. 4 times 1 is 4, divided by that is 2y, minus 12 equals 4 times 3 is 12, divided by 4 is 3y, 10 times 4 is negative 84. Now it's like the beginning of the lesson. If you master those skills, you should be able to fly through this now. Minus 2y, minus 2y would be y, 4 equals 12. Add your 84, and you're done. So y is equal to 72.
Nice.
And we don't care how you get it, it's just fast speed matters on the ACT. Speed, speed, speed. Try it.
Quick pause. Give it a try. Okay, so again, you got a couple different options. Like Mr. Greg said, if you wanted to change it to decimals, you could even go ahead and add a 1/3 or a 0.333 to your 5. Or if you want to multiply, you can do that as well. What I would probably do is multiply everything by 5. Multiply everything by 5. It's going to get you whole numbers. So I'll multiply everything by 5.
5? Is that the common denominator? Or is that just a number?
What do you think? Not the common denominator. Would still work.
Yeah, we'll get 5/4 minus 5/3, and then we're in the same boat we started with. Good non-example.
So let's multiply everything by 4. 4. Now we'll get it.
Does 4 work?
Does 4 work?
Is that a common denominator?
No, doesn't work. You multiply everything by 12. Does that work?
Yes. Trying to drill this into your brain. The more you do,
12 times 5 is 60. 12 times 1 is 12 divided by 4 is 3x. 12 times my negative 1/3 would be a negative 4. Now it gets to where I think you guys can handle this one. This is just simply a 2-step equation. Add 4, add 4. So 64 equals 3x. 64 divided by 3. So divide 3 to both sides. And you get a 28.
we'll get a repeating decimal. 28.
What do you get? 2, 6. No, you get 3, 2, 21.1.
3 repeating, yeah.
21.3.
Repeating. But we're not going to be picky with that. We'll be happy if you can give us 64/3. And in another lesson, we'll go over how to change that to 21 1/3 to a mixed number. That's a whole nother lesson. We ain't got time for that. All right. Good job, Ramsey. Woo. All right, here we go. Here's some bigger application. This ratio is equal to that ratio. Yeah, spotlight it. Yeah. So what you've learned back in the day is this cool little butterfly method. I've heard that. I've heard it all. This and this multiply should be equal to that times that. That's a fact, and it works because we said they're equal. And that little knowledge is how we're going to solve this. We're going to do that. We're going to say 5 times this, x plus 2. Because that's what they said. I could take these and do that little butterfly method. And it should be equal to 3 times x plus 7. So now, checklist. Distributive property. 5x plus 10 equals 3x plus 21. Then it gets back to everything we've been doing so far today, so I'm just going to quickly write the work over here. We got 2x equals 11. So x is 5.5. So if you keep working that out, you should get 5.5 or 5.5. So down here at the bottom, it's a little different. So, drag this out of the way. Bam. It's not really a ratio, but it is. It is. That's 5 over 1. So we can do the same thing. 5 times that. So 5 times x plus 3 should be equal to 1 times that. Oh, that made life a lot easier. 5x plus 15, distribute property first. Then we look through, there's no more like terms on either side, so we move the variable over. Minus x. I'll move that over there, equals 8. And x is 2. Good, I'm flying through this. You know how to work it out. Hopefully you've mastered that. If not, Khan Academy and these other places will supply links to Google Forms. Last slide. Take it away, Coach Ramsey.
So, similar to one we just did a couple seconds ago, the butterfly effect is what I would like to call it. Let's go ahead and multiply my 2x minus 4 times my 9. Let's distribute my 9 to my denominator on the right. Uh-oh, I don't know what happened to our video.
Should be working. Is it?
I don't know if you guys were seeing that. It was black. It was like black screen. All right, we're ready. Let's multiply our 9 times our 2x. That becomes 18x. 9 times my negative 4 is negative 36. Kind of a similar thing up here. Let's distribute this entire bottom, this entire denominator, by a 11. Right? So 11 times 2 is 22. 11 times negative x is negative 11x. Now it looks like some problems we've already been working through. There's nothing to distribute, so let's get our x's on the same side. Right? I'm going to add 11x over here. So now I've got 29x minus 36 equals 22. To get my x by itself, I'm going to go ahead and add 36 over here. Oh,
Fumble. Got it.
That's 29x.
It's still clean. I can use it.
Equals 58. To get x by itself, I'll divide by 29. You guys are pros at this already by now. So x equals 2.
Yeah. That's the end of the lesson. And this is why I dropped my spoon. I was just playing because my brain's dead. We've done this 40 minutes. My bad. But you can pause it. We got a cake because we're doing it. Have a good day.